Algebra 1, Unit 2, Understanding Functions, Lesson 3.4, Graphing Functions. Okay, guys, this was the warm-up. Pause the video. Okay, and this is the answer. And if you could do this problem on your own, you're probably in pretty decent shape. And this is what we went over in class. So if you have some issues or anything like that, any questions, make sure you come see me. This is basically a summative exercise for section 3.3. Okay. All right, guys, here's 3.4 lesson. Graphing functions. Let's talk about graphing functions. So let's recall that the domain of the function is the set of the input, right? And the range is the output that is connected to or corresponding output value or y value of the function. So we have various names for x and y, and they all mean pretty much the same thing, but there's a slight different nuance to them. But we'll learn them as we learn algebra over the years. But for now, this is good. Um, One of the things is the key thing about graphing is that you could think of as the function as a ordered, very specific ordered pairs, right? Ordered pairs, and such that if it's a function, right, it passes the vertical line test, right? And this is a bit of a review. So what is a vertical line test, right? Let's say you have a function that looks like this. It means that for each x value here associated, there's two different y values, right? So if it doesn't pass vertical line test, then it is not a function. That's basically what it means, right? All right, guys. So let's do this. How do I graph x plus 3y is 15? And when the domain is 0, 3, 6, and 9. Well, what we need to do is to solve for y. And when we solve for y, we must think isolate. In other words, get y by itself. So when you do that, that'll be 3y is equal to negative x plus 15. I like to put x in front of the constant. And then we divide by 3. That will yield us negative 1/3 x plus 5. So as I mentioned in the past, think of equation or even a function as this little machine, right? So the domain is the input. What are we putting into the machine? We're putting in 0, 3, 9. And what corresponds to 0 when you do that? You plug in 0. Negative 1/3 times 0 is what? 0 plus 5 is 5. And so on and so forth. So that's the essential idea. But the way we actually do that, um, perhaps it's easier to do it, is make maybe a table over here so it has more space to do the work. So you get negative 1/3, 0 plus 5 is, that is equal to what, guys? That's 0 plus 5 is 5. So this is the x, so this is the output of the y, so we put 0, comma 5. And you keep doing that, and you'll end up with 3, comma 4, 6, comma 3, and 9, comma 2, right? I don't know if you noticed, but the numbers that I chose, right? If you have a choice of trying numbers, notice that all the numbers are multiples of 3. The reason is that it cancels nicely with the 3 in the bottom. So let's try just one of them, right? So negative 1/3 times 6 plus 5. What would that equal to? That's negative 3 plus 5, which yields 3. Hence the 3 right here. Okay, guys? All right. Go ahead and fill out the rest. And the way we would graph this is with x equal to 0, my y is 5. Uh-oh, 5 is like somewhere in the middle here, right? Oopsie. Give me 1 second. Let me do it this way. Okay. There you go. So 5 is around there. I'm gonna make copy, paste, and maybe one more. The next set of numbers, sorry about that, that's a 3, 4. 4 is here, 3 is about there, right? And then 6, 3, 6 is right there, 3 is about there. And then 9, 2 will be, 2 will be here, but 9 will be about there. Is that right? 6. Yeah, that's right. Okay, there you go. And then what you do is you draw a line through the middle. Like that. There you go. And it's a really good idea to leave a little bit of evidence that you there's a reason why you made that line. You can't just make a random line, so make sure you draw stuff like that. Okie dokie. All right. So that's how you do that, but I think idea of plugging in a whole bunch of number repeatedly all the time for every function is quite tedious, isn't it? So the way we would do that actually is, let me copy this right here, slide it down. Oops. Oh, I don't have it. Okay. Then why don't we do this? So how else can I graph? Let me see if I could do this. Let's copy. Let me slide this out of the way first. Copy, paste. There you go. I made extra copy of that, and then let me move this back where it belongs. 0, 5, which is about right there. That should be good. Okay. So how do I graph this thing? Right? So one of the ways that we could do this right here is that this right here is known as a y-intercept, right? And then so it comes like, say, here, right? And this is the slope, which is change in y and change in x is negative 1/3, or you could run 1 over negative 3. Either one works, right? So what I can do is maybe go down 1, so change in y, down 1, right 3. 1, 2, 3. But you don't have to respect this right here, right? So you don't have to go have that as a 1. You could literally go 1, because what's important is the ratio, right? 1, go down 1, go across 3. 1, 2, 3. See that? So we'll end up with 1, 1, 2, 3. See this right, you guys? And when we do that, this point and this point is exactly the same, right? Or we could go the other way. We could go up 3 and left 3. Go up 1, 1, 2, 3. Right there. And then we get a picture this way. Okay? And that's an alternate way of doing it. Oopsie. There you go. And that is the line. Okie dokie. All right. Let's move on to the next set of problems. Right here, guys. So, graphing function using domain of all real numbers. First step is to use the function to generate order pair by choosing several values of x, plot enough points to see pattern for the graph, and connect the line with a smooth curve. So that's what you can do. And we have this right here, guys. Okay. So now what do I do? Previously, and we've done this many times before, right? The linear equation. So that this method seems very familiar, right? But let's come back to this. You notice that this is a square. So what do I do? Well, the method is exactly the same. Okay. So let's start with 0, because that's probably the easiest thing to do. When I plug for 0 here, guys, right? So y is equal to 0 squared minus 2. 0 squared is 0, minus 2 is just minus 2. 0 minus 2. And then when you plug in 1, squared minus 2 is minus 1. So that is 1 minus 1. But I'm going to go up here and put a negative 1 squared minus 1. That's 1 minus 2, which is minus 1. Oh, wow. Did you notice something? That the y value here and here is exactly the same. Is that coincidence? Right? Let's try one more. 2 squared minus 2 is 4 minus 2 is 2. So it's 2, 2. 2, 2, sorry. One to see if you know if it's a coincidence or not is to actually look at it. If I had, instead of put plus, if I had put minus over here, would you come up with the same answer? Because 2 squared and negative 2 squared is the same, isn't it? Right? Oh yeah, it is. So what you notice is that, so once you notice that it has a bit of a symmetry, you could use that to your advantage. So what we can do is using that information, 0, negative 2. Okay, let's do this now. Let me just write down a whole bunch of points. Okay, 0, negative 2. I like to use the one in the middle. 0, negative 2 is about here. And what's the next one? 1, negative 1. 2, negative 1 is about there. And 2, 2. 2 is right there. And then we're going to put similar values here. And copy paste. Okay, so let's try one more, shall we? So we do realize that in this particular case, whether it's plus or minus, it works the same way, right? Plus or minus 3 squared minus 2 is 9, minus 2 is 7. So it's 3 and 7 works, and we know that minus 3 and 7 works, okay? When you see that when you see a pattern, you could use that to your advantage, right? So it's 3 and 7. And let me see if I could make good use of that. 3 and 7, that's a 6 right there. 7 is right there. About right there. So what you will notice is that, let's zoom in a little bit. It appears to be curved this way, right? And it should be. And understand that this should be a smooth curve, so do the best you can. Oopsie, that was a little too thick. Let's go with that one. Okay. Like that. Like this. Okay. So that's the graph. All right. All right, guys. And you could do the same thing for the example B. Why don't you go ahead as an exercise and fill that out. And what you'll find is that the picture will look something like this. So come here, oopsie, 2. Notice that there's a negative value right here, guys, right? So that's kind of important, right? So instead of the number getting bigger, we are subtracting, so the number sort of decreases, right? So what I did was find the y-intercept to say, hey, what if x equal to 0? Then y is 2. And let's think about this. If you move either 1 to the right or 1 to the left, it is negative, plus or minus 1 squared is 1, isn't it? And then we're subtracting, so we move down by 1. Oh, okay. So if you do that, move right 1 and down 1, so we're going to end up with this point right there. If you go 2 to the right, 2 squared is what? 4. So it means that if you go 2 to the right, you're going to go down 4. 1, 2, 3, 4. You'll end up here and here. And then if you go 3, 1, 2, 3, 3 squared is 9. Negative 3 squared is also 9. So that's 4 here. 5, 6, 7, 8, 9 right there. Yeah, so that's how you could do that quickly mentally, right? If you get better at arithmetics, right? Or you have the choice of filling in all this information, okay? All right, guys. So I'm going to leave it up to you to fill all this information out. But this will be 0, 2. Once again, if you plug in the 1, we are subtracting. So we're going to subtract 1. And if you go 2, you're going to subtract 4, which gives -2. If it's a 3, 3 squared is 9. You're subtracting that from 2, which is -7. And the rest is the mirror image. -2, -2, -3, -7. Okie dokie. All right, guys. Let's move on to the next example. All right, guys. So use the graph f of x when x equal to -2 and x equal to 0 for each function. Okay. Why are they asking us to do that? Might be asking, right? So when x equal to -2, right? What happens? F of -2 is -1/2 times -2 plus 3. That is, oops, let me make it a little bit bigger. That is 1 plus 3, which is 4. So that implies that when x is -2, y is 4. What if x equal to 0? So that becomes 0 is equal to 3. That implies that 0 and 3. Oh, got it. Here's the thing, guys. When you recognize that this is a linear equation, right, you only need 2 points to form a line. However, generally you should have the third point, as you're taught in middle school, to make sure that you didn't make any mistakes, right? All right. So this is the purpose of this. So we got a point on 0, 3, which would be 0, 3 is like about here. -2, 4. -2 is about here. 4 is about there, right? And it seems like we need more points, right? So one of the ways you could do this is what? My y-intercept is 3, right? What? This is the y-axis. So you go, sorry, 1, 2, 3. So we got that. So what is my slope? -1/2. But that's changing y and changing x. But you could also write that as 1 over -2. So you could use that to guide the way we graph things, right? To answer your question, what is slope? We only need this part right here, okay? That was extra that I wrote down, okay? All right, so this one says my y is -1. So we go down -1. So sorry, we go down 1 and we move right 2. Let's do that, shall we? So we go down 1, right 2. Down 1, right 2. The more points you have, how about this one? For this one, I'm going to use this point to start, right? According to this, I'm going to go up 1 and left 2. Up 1, left 2, up 1, left 2. And there you go, guys. Okay, I'm going to slide that over just a tiny bit more. Okay, slightly off, but I don't have the luxury of the rulers here. Okay, there you go. That's it. So I'm going to go a little bit faster on this one. Okay, f of -2 is, oops, that, you know what? Let me change the thickness of the line. That's affected my handwriting. Okay, thought that was great to begin with, but I need all the help I need. 3 over 2, -2, minus 4. So 2 and -2 gives you -1. So that's -3 minus 4, which is -7. F of 0, that goes to 0, right? So it's -4. So we got 0, negative. And we could do that. It's probably a good idea. But at the same time, we should use slope, which is 3 over 2. Or in this case, -3 over -2. That's the same thing, right? Because that helps you go in different directions, right? And then what's the y-intercept? -4. Okay. All right, let's do that, shall we? What is my y-intercept? -4, which is here. And then if I use slope, we go change in y, change in x, guys. Remember that? Change in y and changes in x. The numerator tells you how it moves up and down. The denominator over here tells you how it moves left to right. So we go up 3. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. We'll go down 1, 2, 3, and left 2. Right there. And when you connect these lines right there, there you go. Let me move it slightly down this way. And that's how I draw the line. Let's check. Instead of using that to graph, let's check if we got -2, -7. -2 is over here. If you go straight down, yep, that's between -6 and -8. Right there, -7. Check. Okay. All right, guys. Do me a huge favor. Right? And go ahead and try your turn 4-7. Please pause the video. Okay, here are the answers. And then here are the bottom 2 questions. Okay, guys. All right, that's everything. So if you have any questions, please don't forget to come see me. Otherwise, have a good night, okay?